Okay. Today I'm speaking with Jens from Gestalt Robotics. We actually met during a startup night here in Berlin, and we spoke about startup night a couple of episodes ago. But I was interested in speaking further with Jens because him and his colleague proudly mentioned that they program robots. And I was interested in finding out exactly what that meant. So, Jens, welcome, and tell us a little bit about what you do and Gestalt.
Yeah, hi, Chris. Thanks for having me here. I'm working with robots since over 10 years now. So I started with classic industrial robots, and during my studies of mechanical engineering, I did programming for industrial robots and simulation for industrial robots. So industrial robots are existing since the early 80s. And most people doesn't recognize and doesn't know that there are robots working in the factory since decades. And but they are doing already a lot in factories for automation. And so these robots mostly do repetitive tasks. So tasks that are the same all over again, and the robots can do it 24/7, for example. Mm-hmm. And typically they're doing stuff that the humans don't want to do because it's it's always the same. It's boring work. Maybe some industrial robots are also doing work in a dangerous environment. So these are good tasks for industrial robots. And now last year I founded this company after working for big German companies, after working for the university and doing my PhD, because we had a lot of experience in programming robots and also combining computer vision to robots to give them a little bit more intelligence than they typically have right now. And so to be specific, if you're asking for programming of robots, so this always means that you have to, if you're programming the robot, you have demands, typically from a customer. He wants to automate services or production tasks. And so during the programming or via the programming, you're telling the robot what to do. Mm-hmm. And so this is mainly an coding issue. Mm-hmm. And but there's a huge difference, for example, between industrial robots and service robots, mm-hmm. regarding the coding and regarding programming languages and so on, and also regarding the abilities the robots have. Mm-hmm. So, because in general, the main capability of robots is their movement. So a big part of programming robots is telling the robots how to move and where to move. Okay. So for the industrial arms, for example, you can imagine that you're programming these trajectories in space, you're programming poses. Poses are important in robotics. Poses are positions and orientations. So you're defining positions and orientations in space, telling the robots where to go, and there are kind of methods how you can tell the robots where to go. In industry, for example, it's mainly remote control. So you're driving the robot with this tool to the desired positions, and then you click on save, and so the robot controller is saving these positions, and afterwards you can write a program in the robot programming language, and you can use these positions and tell the robot, okay, first do this, then go to this position, then close the gripper, for example. And so this is a typical procedure of programming industrial robots. And maybe what is interesting regarding industrial robots is that every robot manufacturer has his own programming language. So we are really struggling with this, and every robot manufacturer in industry has its own interfaces and so on. And if you do fancy stuff with robots, programming them with external brain power, for example, external reasoning coming from computer vision, you always have to mess with these manufacturer-specific interfaces. And that's a big mess in industrial robotics that we have. So if you're writing code for example, a robot from the manufacturer KUKA, you cannot use it with copy and paste for an HP robot, for example.
But are there at least common languages? Is it often C or Python or Java or all of those?
I wish it would be like this, but for the industrial robots, it's mostly the robot manufacturers define their own programming language.
Oh, really? Wow.
Yeah, really. So they're similar to high-level programming languages like C or sometimes Java, but they always have their own syntax and so this is a thing you always have to deal with in industrial robotics, and it's not so programmer friendly.
No, okay.
I think there were motivations in the 90s to get a standard here, to have common interfaces for all industrial robots and common programming languages for all industrial robots, and there have been standards. And ISO norms, for example, but the manufacturers just ignored these norms and told the programmers here use our programming languages. They are better, and this was just I think it was because of proprietary product policy. Yeah. But you can consider some trends also in industrial robots that some manufacturers are offering, for example, education platforms where they are open for programming languages like C, for example, and also Java, and very popular in robotics in general is Python.
Okay.
And I became a big fan of Python during the last years because you can do coding and just writing a little script for robots, for example. If you're just testing something, you can write it so easily and within minutes. And it's not the best choice for real-time tasks, for example, Python and other scripting languages in robotics. So you would use C or C++ there, which is more hardware near programming. But for programming procedures for robots, for example, first go here, then look there. If you find an object grip it and bring it to me. These kind of procedures could be described very easily and very fast with script languages like Python. And so you see this trend in industry that also maybe in the future the big industry manufacturers of robots are adapting trends like open source and so on. But I think industrial robots are mainly based in the domain of mechanical engineering. That,
Yeah.
this whole domain is quite conservative, especially in Germany. So there must happen a complete disaster until they are changing their policies. But we're going step by step here.
So your background is industrial robots, but if I look through your webpage, which is full of quite entertaining photos and videos, there's a lot of more service robots. And when we met you, you had service robots. You had, I think, a Sandbot, and I can't remember if you had a Pepper, but Peppers pop up everywhere.
Yeah.
So I'm guessing then from what you're saying that these you program differently. These are more user-friendly for developers or not
Yes.
yet? Yeah, they are.
Yeah.
Okay.
Yes, exactly.
Okay.
So I think I'm now also dealing with service robots since about 2 years now. And we started developing with the Pepper robot, and this is also why we started the company, because we had potential contract work here for doing showcases with these new service robot platforms. So in comparison to the industrial robots, they're cheaper and they are mobile. So they have a mobile platform and they can move, and they also have other features like speech recognition, speech output, and typically they also have cameras included, and typically they also have a display. And the programming here is completely different. It's let's say it's made easy for the programmers. So because most of these robots, you can just program it like Android devices, and actually they are extended Android devices, and so that's very friendly, for example, to find programmers, because I think the community of Android programmers is quite huge worldwide. I think you will find Android programmers in nearly every city around the world. And then back to industrial robots, that is very specific. If you are looking for a programmer for KUKA robots, for example, so you won't find so much programmers specialized to KUKA programming language, and even their salaries are quite high. So with the service robots, the great thing here is that the approach for programming is completely different. You can program these service robots in most cases with Android, and the programming languages here, mainly Java. And so that's very friendly to also get new programmers to robot programming, because there are, especially also in Berlin, a lot of programmers for Android. And what comes here in addition is that you have additional functions for controlling the sensors and actuators of the robots. It's like that you are writing an Android app, and so you can also write the front end. It will be shown on the tablet that is implemented in the robot. And then you're just using these additional functions to control the motors, for example, for the robot, for this mobile platform, to move it. You can use additional functions to do the text inputs, the text output via speech. And these are some basic functions the robot hardware that we have right now brings, if you, for example, buy these kind of systems. And then all the intelligence that the robots should bring, or that people expect from these robots, all of the intelligence comes on top. And so, for example, that's where we started That's our main business, that we are taking these existing service robotic systems, coming with sensors, actuators, and Java RP for programming, and then we have the demands of our customers. For example, we started with a Pepper robot and had customers with demands like, we have a talk of our CEO here in this event, and we want to have a discussion with our CEO and the robot on stage about the future of work. For example, that was one use case we did, and so what we got was, for example, here a scripted dialogue for CEO and robot, and then on these robots you also have additional tools to set up dialogues, to script, for example, words, sentences, and then use them as a trigger for an answer.
And in fact, there was one I saw this morning, Sophia at the UN yesterday.
Okay. So there was a robot.
She told the UN, "I'm here to help humanity create the future."
Okay.
And it was one of the more realistic-looking ones, which are always a little bit disturbing. But but it's interesting that you say this, because it sounds like still, especially with the service robots, I suppose, which are at the in quote marks the cheaper end of robots, because they're not probably still that cheap, but it still sounds like they have to be very specifically programmed for each use case. It's not like you can just send one out and it learns as it goes, and you really have to know the sort of 10 use cases it's going to be used for in each location and make sure it covers those. And if someone asks something it doesn't recognize, then it's stuck, pretty much.
Yeah, I mean, so these kinds of robots typically right now are not bringing intelligence out of the box. They are just hardware, and what you're finally doing with it, and what the robots are finally able to do, this depends very strongly on the capabilities of the programmer and what you can do with the sensors and the actuators. And I think in the end, the robot is as intelligent, maybe, as a programmer. So, and then, so our policy, for example, or our approach to this is that we are working on modules, and to have modules, for example, to visual perception. This is also one strong part of expertise that we have. That we have some computer vision experts here, and they are working with the 2D and with the 3D images from the robots, and they are analyzing it with machine learning algorithms, for example. And so the first motivation that we have here is to let the robots understand what is in their environment. So, because so that's just the first step in this whole intelligence thing about the robots. If the robots don't understand what they see and where they are, what should you do with the robots? So, you can do speech input and output, and it wouldn't be anything else than Amazon Alexa or Google Home, what you have there right now. And so without any intelligence, these service robots are, I think, nothing else than a little bit animated Android tablets. And so this couldn't be what you expect, and that isn't what most people expect. And for these kind of applications, also the service robots are still too expensive. So nobody would buy a service robot for 20,000 euros, for example, to just use a tablet and make the arms move or something like this. But by the way, for some cases and fairs and maybe shops for promotion, it works. Yeah. And to be honest, that is right now. This is a use case how service robots are mostly used. So they just put it somewhere in shops or on fairs, on to the booths to some companies, and the robots are moving, saying something, and looking nice, and so they are gathering the attention of the people there, and they're doing promotion for their products. Yeah. But their potential. What you can do in theory with these kind of systems, so you can do so much more things, but you have to bring your skills to achieve these kind of intelligence. And so we are just starting with some basic things like object recognition, and we are using, for example, here a lot of deep learning, which made real enhancements during the last years. So right now we are able to recognize for our robots that we have here a set of more than 80 objects, for example. And we can implement these algorithms to our robot and let the robot recognize these set of objects. We can also train new objects. And so these are the very basics to let the robot recognize objects. Next steps are, for example, to create something like mind for the robots. So in literature, this is named as temporal spatial minds. This is what we humans have, that we can remember things, and especially things that we saw. So we remember objects that we saw, for example, and we have an idea when we saw these kind of objects. And so this means for the programming of the object for the robots that we have to build these algorithms to detect robots, so to detect objects. So we're using here a lot of deep learning. In the next step, we have to build algorithms that we recognize objects and, for example, also people that we have seen before. So, for example, that the robot can also see differences between people, see differences between objects, and so on. And then we can combine it, for example, with other features of these service robots. For example, for the navigation, that's another module, another topic. And typically in service robotics, so you're building your 2D maps of the environment. So this is like that if you're using the robot in the first place in a new environment, for example, the robot goes and explores the environment, and it's creating a map of its environment. In most cases, based on laser scanners. So he's driving around and he's recognizing, okay, there's an obstacle, there's some free space, and then you have a map. And you as a human, you can also have a look on this map, and you can understand it. So typically in this map, this is nothing else than an image, and you have obstacles in different colors in free space, for example. And so regarding the navigation of these kind of robots, so the initial way to interact with these service robots, and for the navigation, the task is tell the robot where to go. You would have this map, and you would click on specific points of the map, of these 2D map. Mm-hmm. And so what we are doing right now is that we are bringing together these navigation modules with these modules regarding object recognition and also object instance recognition, because I think for the end user, I do not think that it's appropriate to let them click on points on the map to tell the robot where to go. That's not a kind of natural communication with the robot. So basically, what do we want for communication of robots? I think the best case for humans would be if we can communicate with robots like we do it with other humans. Mm-hmm. So I think, and that's the overall objective in human-robot communication, to make it very natural. And so coming back to navigation here, is what would you do with a human colleague if you want to give him a task like bring me a cup from the kitchen? You want to say, you would say it to your colleague, and your colleague would understand, because he's identifying words. He knows. He's identifying the word kitchen, for example, in the first step, and he knows where the kitchen is on the map. But you're not telling him, for example, in this case, where's the kitchen. You don't need to, because he knows, and even maybe if he has never been inside of the kitchen, he would recognize the kitchen if he sees it, because they are specific objects, and then he can say, okay, they're these and these objects. It must be a kitchen here.
Okay, yeah.
We want to close this gap now in robotics. So this is something we are calling semantic navigation. Because we don't want to do the old way in navigation, to have a 2D map and let the user click on these maps to tell the robot where to go. We want to tell the robot where to go via speech, via just natural speech, telling him go to the kitchen, for example. The robot knows where the kitchen is, based on also the objects that you recognize. So like a human, if you're recognizing, for example, then you're recognizing a fridge and some other objects from the kitchen. So the robot knows this is the kitchen, and can bring these kind of informations together. And what also comes with this is that the robot not only recognize objects, he's also putting these kind of objects in a spatial context. So he's combining the map, where he knows where he is, and also he knows now where the objects is. So we're throwing these objects to the map, and creating a map which is enhanced by objects, and then we can use it for the navigation and tell him, okay, go to the kitchen, go to a specific object, and then the robot knows where it is and where to go. And this is something where we are working on right now, these kind of what we are calling semantic navigation.
So for anyone interested in programming a robot, could you recommend a sort of is there a Hello World alternative for programming a robot? How does someone get started? Is there an affordable model you recommend, or how how would anyone get started programming any kind of robot that might be interested?
That's a good question. I think for the early stage to get an idea what robot programming is about. So mainly it's about to work with sensors and actuators. And, to get a first insights here, I think these kits, for example, from Lego, for example, Lego Mindstorms, they are a very good introduction to these topics, and you can see awesome projects on YouTube, for example, where people build awesome stuff, awesome robots, awesome automation lines with Lego Mindstorms, and so I think it's pretty much the same like programming other robots. So you have this same principle over and over again for the real service robots and industrial robots. Of course, you may have other kind of sensors and other kind of actuators, but to get a first idea what robot programming is about, I think these Lego Mindstorms is it's awesome, and they are also from other vendors.
There's quite a lot, yeah.
Yeah, there's quite a lot. It's for example, there's a company. It's called Tinkerbots from Bernau near Berlin. They are building toy robots based on Arduino microcontrollers, for example. They are combining it with very fancy interfaces, also on smartphones, and very easy interfaces for programming the Arduino. So this is great stuff. And if you're a little bit more sophisticated and you may have real programming expertise, especially in Python and C++, you may have a look on a great robotic framework that is called ROS. ROS stands for Robot Operation System. So ROS is becoming a kind of standard in service robotics, and ROS is a lot. ROS brings communication middleware for robots. It's bringing tools for simulation of robots. It's bringing huge software frameworks for robot control functions, for computer vision, and everything. So basically, you can lose yourself in the ROS framework, but there are also very easy samples in the net where you can just use simulation and use all the open source features. So ROS is open source, so it's you can use these awesome simulation tools there, and just get your models of. You can get models of a lot of service robots there, and you can just start with first steps. There are great tutorials, and try to control these simulated service robots, and then you're getting an idea. You're writing your first remote control for these simulated service robots, and you can also do that within, I think, a couple of hours. So you don't need to read documentation of ROS, even if it's so huge. For some very easy tutorials, you can do these tutorials within some hours, and then you can go further with ROS if you like it, and if you like robot programming, you can go step by step. First has a great community. It was driven during the last years mainly from academia, but right now there are also many people from companies like our companies in the community, and also some people that are doing robot programming, for example, for their hobby. You can even use the ROS framework if you're building your own robots, for example.
Okay.
So this will be my recommendation here.
Excellent. And finally, so I've again looking through your webpage. You've been at lots of events. You've actually been at several events I was at, and I only noticed you at one, so that's bad of me. But anyway, what's next for Gestalt and for the company? What's your plans for the next 6 months?
We will continue joining events. We will be, for example, here in Berlin on the TechCrunch Disrupt event in December. And so what else? Well, we are going to participate on a hackathon of Prop Down Gamble for robotics and automation. And I think in the next year you will see us on the Automatica fair in Munich, which is the biggest fair regarding automation technology, I think, in Germany, and I don't know if it's worldwide. And of course, next month we are participating in a conference also here in Berlin. It's called Deep Berlin, and it's organized by the company Hella Aglaia to getting companies and a community together which is dealing with deep learning, and to get an exchange here. And we are also we are going to present our semantic navigation approach there on this conference. Excellent.
Okay, and how can people stay in touch with what you're up to? I think it's gestalt-robotics.com, yeah?
Yes, it is. You will also find us with Google, and we are doing a lot in social media. We have a YouTube channel. We are
with lots of entertaining videos. Yes.
That's true. And you can also follow us on Twitter. So we have also a lot of snippet videos, for example, from some development tasks, that just short videos that we are not publishing on YouTube, for example. So it's worth to visit us on Twitter, and we're also on Facebook, and we are planning to also start an Instagram account.
I think I like your approach, because a lot of people are still a bit disturbed by robots, and making them seem slightly fun and funny is a good approach, maybe.
And we have to do promotions that so robots are not meant to they are meant to support the humans.
Exactly. Exactly.
Replace the humans. For example, the full automation approach with replacing of all humans, that is like 90s of the last century. No real roboticist would tell you, okay, we're using robots for everything and replace humans. So this is a little bit outdated. We're using this technology to support humans as best as the technology can, and always in combination with skills and abilities of the humans to make a perfect team here.
Okay.
Of humans.
It's actually that's an interesting point to end on. My wife and I are actually doing an event tonight for one of the sites that we write for about this very topic. And we're supposed to take different sides of the argument, but we kind of agree. but it's for fun, it's that sort of aspect. But I like the way you said that that's an old way of thinking, and let's hope that that is the case moving forward. I think there's a lot of potential for robots and automation and AI to help us, and let's just hope that everyone sticks to that.
I think so. I'm convinced.